So today we are going to learn about technique of integration. So first thing first, we have four parts of integration substitutions. The first one is the basic integration. The second one is trigonometric functions. The third one is polynomial power, and the last one is definite integrals. So as you can see, this is the formula of U-substitutions. So Fu du equals to Fu plus C. Fu is indefinite integral of a function, where Fu is its antiderivative and C is the constant of integration. Next, U is a new variable which is a function of x. And then du is the differential du that derived from u equals to gx by differentiation. We use this substitution to rewrite the integral in the terms of u, making it easier to solve. So basically, this is the fourth step of u substitution. The first one, we need to let u equal to gx, and then find u, and then the third one, rewrite the integral in the terms of u, and then solve and substitute u back. Okay, now here we have substitution of basic integration. So this is the first example. We have here evaluate integral of 2x exponent to the power of x squared dx. So go back to the first step of u substitution. Firstly, we need to let u. So in these questions, we have to let u equals to x squared. And then we differentiate the u, du over dx, we got 2x. And then from the equation, we got du equal to 2x multiplied by dx. And then we substitute u into the equations. So we got integral of 2x exponent to the power of x squared. And then we cancel out 2x and dx. We got the du that we did just now. So we got integral of e to the power of u du. And then we integrate this. Then we got e to the power of u plus c. And the last step is we substitute back u equal to x squared. And then we got exponent to the power of x squared plus c. So this is the answer. Okay, let's go to the last example of basic integration. So in this example, we have evaluate integral of x over square root of x plus 1 dx. So as usual, we let u equals to x plus 1, and then we differentiate, we got du equals to dx. And from u equals to x plus 1, we got x equal to u minus 1. And then we substitute all of the u substitution into the questions. So we got integral of u minus 1 over square root of u du. And then we separate the u and minus 1. We got integral of u over square root of u du minus integral of 1 over square root of u du. And then we turn it into the simpler form, which is integral of u to the power of 1 over 2 du minus integral of u to the power of negative 1 over 2 du. After that, we solve the integration. We got 2 over 3 u to the power of 3 over 2 minus 2 u to the power of 1 over 2 plus c. And then the last step is substitute back u equal to x plus 1. We got the final answer is 2 over 3 x plus 1 to the power of 3 over 2 minus 2 x plus 1 to the power of 1 over 2 plus c.
Assalamualaikum and hi everyone. My name is Aina Syafiqah binti Muhammad Aidil and my magic number is B202211029555. Today I will explain about substitution with trigonometric function. When dealing with trigonometric integrals, Substitution can simplify the expression by using non-trigonometric identities or derivative. We will look for example 1. The question is evaluate integral sin 2x dx. Recognize that the integral sin 2x dx can be solved using the substitution method. Firstly, we need to let u equal to 2x, then du over dx equal to 2 and dx equal to du over 2. Rewrite the integral in terms of u. Integral sin 2x dx equal to integral sin u multiplied by 1 over 2 du. Apply the constant multiple rule for integration. Integral sin u multiplied by 1 over 2 du equal 1 over 2 integral sin u du. Integrate sin u with respect to u, which is negative cos u plus c, where c is the constant of integration. Substitute back u equal to 2x to get the final answer. 1 over 2 integral sin u du equal to negative 1 over 2 cos 2x plus c. Next, we will look for example 2. The question is evaluate integral x cos x squared dx. Firstly, we need to let u equal to x squared, then du over dx equal to 2x, and dx equal to du over 2x. Next, we need to substitute u and dx into the integral x cos x squared dx equal to integral x cos u multiplied by du over 2x. We can simplify the integral x cos u multiplied by du over 2x equal to integral cos u multiplied by 1 over 2 du. We need to factor out the constant for integral cos u multiplied by 1 over 2 du equal to 1 over 2 integral cos u du. Since we know that when we integrate cos u, we will get sin u plus c. So, when 1 over 2 integral cos u du equal to 1 over 2 sin u plus c. So, we need to substitute back u equal to x squared, and we will get the final answer is 1 over 2 sin x squared plus c. That's all from me. Thank you.
Hi, my name is Shahira, and today I'm going to teach on how to solve the integral of x bracket of x squared plus 1 power of 5 dx. So there's actually 5 simple steps on how to solve this integral. So for the step 1, we have to understand the structure of the integral. So the given integral is x bracket of x squared plus 1 power of 5 dx. So we can actually notice that the term bracket of x squared plus 1 power of 5 is a composite function. So a composite function means a function inside another function, like bracket of x squared plus 1 power of 5. So the derivative of x squared plus 1 is 2x, and we already see an x present in the integral. So this gives us a clue that substitution is a useful strategy to simplify the integral. So for the step 2, we have to choose a substitution. So to simplify the composite function, let's substitute the inner part x squared plus 1. So we can actually let u equal to x squared plus 1. This means u represent the simpler inside function. Next, we have to find the derivative of u with respect to x. So du over dx is equal to 2x. So we can rearrange this equation to express dx. So du is equal to 2x dx, or du over 2 is equal to x dx. For the step 3, we can rewrite the integral using substitution. Now we can replace the term in the integral. So we can substitute u equal to x squared plus 1 and substitute x dx equal to du over 2. So this transform the original integral x bracket of x square plus 1 power of 5 dx equal to the integral of x square plus 1 power of 5 times x dx. So now we can replace x dx with du over 2. So the integral of bracket of x square plus 1 power of 5 times x dx will equal to the integral of u power of 5 times du over 2. And now we can factor out the constant 1 over 2. So integral of u power of 5 times du over 2 will equal to 1 over 2 the integral of u power of 5 du. For the step 4, we can solve this simpler integral. Now focus on solving integral of u power of 5 du. So the power for integral states power of u n du equal to u power of n plus 1 over n plus 1 plus c. So now we have n is equal to 5, so we can substitute into the power rule. So we will get the integral of u power of 5 du is equal to u power of 5 plus 1 over 5 plus 1 plus c. And we will get u power of 6 over 6 plus c. So now we have to include the 1 over 2 constant. So we will get 1 over 2 the integral of u power of 5 du is equal to 1 over 2 times u power of 6 over 6 plus 1 over 2 times c. And we can simplify and we will get 1 over 2 times u power of 6 over 6 equal to u power of 6 over 12. So the integral will become u power of 6 over 12 plus c. So for the last step, we just need to substitute back u equal to x squared plus 1. Now replace the u with the original expression, which is x squared plus 1. So this will give us u power of 6 over 12 plus c is equal to the bracket of x squared plus 1 power of 6 over 12 plus c. So for the final answer, for the integral of x bracket of x squared plus 1 power of 5 dx will give us bracket of x squared plus 1 power of 6 over 12 plus c.
Hi, Assalamualaikum everyone. My name is Nur Adibapani binti Roslan and my matric number is D2022110291. Okay, for today I will like to explain about the method of integration by substitution, which is specifically on definite integral. Okay, for this technique is incredibly useful for simplifying complex integral by introducing a new variable, which is u, to replace a complicated part of the integral. Okay, so let's walk through the two examples that I need. Okay, first example is, okay, this is the equation x e to the power of x squared. Okay, from x equal to 0 to x equal to 1. Okay, so first we need to substitute. Okay, to simplify this, we start by choosing a substitution for the power, which is x squared. Okay, so let's set u equal to x squared. Okay, so now, okay, we differentiate u with respect to x. So it will be du over dx equal to 2x, or du equal to 2x dx. Okay, so we notice that we have an x dx in the original integral, so we can rewrite that as du over 2 equals to x dx. Okay, this is the step 1. Okay, so for the step 2, we change of limits. Okay, so next we need to adjust the limits of integration to match our substitution. Okay, so when x equal to 0, u equal to 0 square equal to 0. So when x equal to 1, u equals to 1 square. Okay, so 1 square equal to 1. Okay. So for the step 3, we substitute into the integral. Okay, so let's substitute everything into the integral. So, okay, x e to the power of x squared equals to from x equal to 0 to x equal to 1 equals to 1 over 2 e to the power of u from x equal to 0 to x equal to 1. Okay, so we get that. Okay, for the substitution. Okay, so for the step 4, we do the integration. Okay, now we can easily integrate e to the power of u. The integral of e to the power of u is simply e to the power of u. So we will get 1 over 2 e to the power of u from x equal to 0 to 1 to x equal to 1. Okay, so equals to 1 to the power of 2 in bracket e to the power of u from x equal to 0 to 1 to x equal to 1. Okay, step 5, we apply the limits. So now let's evaluate the result by applying the limits of integration. When u equal to 1, e to the power of u equal to e, and when u equal to 0, e to the power of u equal to 1. Okay, so 1 over 2 bracket e minus 1. So the value of the integral is, okay, so the value will be e minus 1 over 2. Okay, to summarize it, we use substitution to simplify the integral. So adjusted the limits of integration, perform the integration, and evaluate the result. So the value of, so for the example 1, we get the answer is e minus 1 over 2. Okay, that's all.